All right, hey friends, this is the short recap for week 34 of my chill kernel hacking for fun streams. I'm going to summarize the 2 hour stream in this recap video. And basically, what happened was I was switching. Basically, I spent the first part of the stream finishing my read through of the code to bring up the application processors, the like alternate CPUs on the system that are not the bootstrap processor. So I was just like reading a bunch of code for a while, walking through the boot up of these application processors. At some point, I move on to I don't know, like looking at documentation at the 15-minute mark, or like even past that. I finish my read through and I start working on an exercise. So I start working on this exercise where I need to tweak my physical memory allocator such that it doesn't offer the physical memory that I'm going to use for bringing up the application processors, because part of bringing up the application processors involves basically copying some bootloader code into physical memory and passing that off to the application processors to boot up. And up until this point, this region where I'm copying the bootloader startup code for the APs, that has been eligible for allocation by the physical memory allocator. And I don't want that to be the case, because that memory could get clobbered. And so I need to exclude that like in the deny list basically for my physical memory allocator. It's not really that hard. It's just adding kind of like one more if statement. And I do that around the 26-minute mark. That's the easy part. Then what I spend literally the rest of the stream on is debugging this crazy issue where the kernel doesn't boot anymore. And I would literally spend probably like an hour and 45 minutes doing really intense deep dive, like low level kernel debugging and bootloader debugging for why my kernel just doesn't boot anymore. It doesn't have any console output anymore. It just keeps rebooting constantly, which is really odd because I didn't do too much. But one thing I did do is I needed to incorporate the new code for the new lab. So I switched from lab 3. Now I'm moving on to lab 4. And I needed to merge Git branches. I needed to merge my lab 3 branch, which I built on, into their lab 4 branch to get their new changes so I can keep following the class. But after doing that, the kernel just doesn't boot anymore for some reason. And it's very mysterious because that merge operation didn't actually change anything with the early startup sequence of the main processor. It didn't touch the boot assembly at all. It didn't touch the bootloader. It didn't touch the linker script, which is important. It didn't touch like anything. But for some reason, the kernel doesn't boot anymore. And in the stream, in the last 5 minutes, I completely just walked through and summarize the whole thing like in detail. I'll try to do another recap of this right now. But it was this really, really interesting and kind of crazy bug where the changes from all this new code from lab 4 added a lot of extra data to the kernel. Global data variables per CPU kernel stacks, and each kernel stack is like several K, at least a page, I think. So it added quite a bit of data to the kernel, which kind of ballooned the size of the kernel binary. And as a side effect, something with those changes caused something to change with how the linker organizes the kernel into segments and sections. And previously, there was only ever one load segment in the ELF binary. It was just the bootloader would just load a single load segment into low memory when loading the kernel. But after all of these new changes, for some reason, and with the tool chain I'm using and stuff, which is much newer than the one they were using in 2018, that caused 2 load segments to be created. And the key thing that was wrong is that the first load segment is specifically crafted such that its physical address is very low in physical memory, because we want the bootloader to load the kernel very low in physical memory. For some reason, the second load segment wasn't getting that directive, and it was using a very, very high kernel virtual address as the physical address for the bootloader to like write to. And the consequence of that is that when the bootloader loaded the kernel, it loaded the first segment into low memory just fine. Then it went to the second segment and loaded it super high in memory. And that second segment contained a lot of very important global data, including our initial page tables that we used to bootstrap the virtual memory. And so that got loaded super high in memory. And then later when the kernel comes along and tries to find its page tables, it's all zeros. And so it's going to unsuccessfully load. It's going to load zeros as the page tables, which is going to map nothing, which is going to cause execution to crash on the literal next instruction that tries to execute. And the fix, in short, was tweaking the linker script to remove some of these sections that are kind of unnecessary for me. We have these sections for stabs debugging info, which they used in the class, but that's been deprecated in my tool chain and I can't use it at all. But I still have these these directives in my linker script for the stabs entries, and removing those, I don't know why, removing those entries causes the second load segment to still be there, but it's correctly adjusted to be in low memory. And so the kernel boots again. That's a short explanation of the bug. You can just kind of like watch me debugging this in all its painful detail. I'm just kind of going through and resolving some merge conflicts to kind of merge the 2 branches together so I can see the diff more clearly. I do quite a lot of kernel debugging. You can see here I'm debugging the bootloader's elf loader code. Just to figure out what's going on. I'm looking at this global data that we have. That's where we declare the page directory. I'm, debugging the assembly to like really confirm that we're in the kernel's entry point. Yeah, I'm checking the Git history to see that we didn't change the entry pager in any way. I am dumping memory where the page tables should be. So the page table should be at this 11,000 thing. I'm dumping that memory and just seeing zeros everywhere. So there should be page tables there. There's not. So that's broken. I'm going through the diff. Debugging, just debugging stuff. I'm commenting out. I'm like taking things away from the kernel that would affect this, that would affect the size of the kernel, like all these new user binaries that are being built in there, taking that away. I'm adding my own global variable to see if that's available in memory for some reason, but it wasn't in the same way, for the same reason that these entry page directories were not. I'm looking into the elf binaries, looking for my global data in there. So yeah, it was pretty much as I described earlier. It was like a really deep dive into the core of the boot process, kind of, but eventually kind of got it in the end and was able to, in the end, boot the kernel. This is what we're seeing here in the top left. The kernel boots again. It fails on some assertion related to the coursework I haven't completed yet, but at least it boots again. So that's it. So that's the short recap for week 34. Thanks a lot for watching, and I'll see you in another one. Peace.